How can regional airports improve traffic control? This presentation describes a state-of-the-art radar system which gives you the most for your radar dollar. The Marconi-designed 10-centimeter band radar system, S511, uniquely combines reliability, simplicity, and advanced technology with high performance at low life cycle cost, all backed up by 50 years of radar experience. But system performance is only the start of the story. It has to be combined with a dynamic organization covering sales, system integration, and logistics support. That is where we come in. Cincinnati Electronics Corporation. As a subsidiary of the Marconi Company Limited, we plan to adopt this product for the expansion-conscious regional airfield market in the USA, where we believe the economics of S511 cost versus revenue potential will be appreciated. Cincinnati Electronics has qualified for integrated logistics support programs. These programs require the ability to provide full field engineering and service, turnkey project management, depot spares and repairs. In other words, Cincinnati Electronics is ready equipped to back the CE Marconi S511 radar installed anywhere in the USA. Our newly formed ATC radar division is organized to provide site surveys, installation services, subsystem integration, test and acceptance programs, and field services. The AVCO Services Division is also a member of our team for on-site maintenance. But you might be wondering, who is Marconi? Marconi Radar, with its headquarters in Chelmsford, England, is proud to bear this historic name. Its parent, the Marconi Company, was the world's first electronics manufacturer. It remains a pioneering organization with a worldwide reputation for innovative quality products and high technology engineering. No radar manufacturer outside the United States is larger than Marconi. Here, and at another plant in Gateshead, is where the widest range of radars and associated subsystems in the world are designed and built. Marconi has had a major role in radar evolution since the 1930s. It has built over 3,000 air defense radars, supplied virtually all the ATC radars, which provide the United Kingdom airspace surveillance system and numerous other national networks. Evidence of advanced design concepts and long-life product support is to be seen from the well-known S264 ATC radar designed in the 1950s, still providing reliable service in the United Kingdom and at many major centers around the world, including installations in France and Italy. By comparison, this is an exceptionally high-gain antenna of Marconi's latest ATC product, Messenger Monopulse Radar Beacon System, with full Mode S compatibility. Time and again, Marconi has demonstrated its ability to design complete systems and to support them. Marconi experience and resources are available to Cincinnati Electronics to ensure a smooth transition for the S511 into the USA market. In 1968, Marconi was acquired by the British General Electric Company, no relation to the American company of the same name. General Electric is the largest electronics group in Europe. It employs 170,000 people and sales were in excess of $6.9 billion last year. GEC provides Marconi and Cincinnati Electronics with financial backing and scientific research, as well as supplying many specialized components and subsystems. Marconi Radar's engineers are constantly stretching electronics technology, searching for new and better ways to solve both old and new problems. Air traffic management studies show that flight safety and expeditious handling, even at smaller airports, benefit from primary radar. It sees all traffic, not just those aircraft with responsive equipment on board. What controllers need from an approach radar can be summarized as better detection of small aircraft, visibility of aircraft tracks through weather and terrain clutter, a bright, unambiguous display, and a high reliability service. Market research pointed the need for a new generation surveillance approach radar for regional airports based upon 4 prime requirements: simplicity, reliability, advanced technology, value engineering. It was against these criteria that the S511 design was specified in the early 1980s. Let's consider some of the highlights. The antenna is a clear example of how a new approach worked in practice. Instead of a metal mesh stretched over a complex structure of ribs, Marconi produced a one-piece molding of carbon fiber reinforced plastic with 2 ribs of the same material molded into the back. It's simple, but it's also an advanced concept. The construction is inherently rigid, and the molded reflector is extremely accurate in profile. Repeatability in production is excellent. And because carbon fiber is a conductor, no metallizing is necessary. The electrical performance of the antenna is exceptional. Furthermore, carbon fiber does not rust or corrode, so maintenance is minimal. The antenna can be used in a wide range of hostile environments, usually without radome protection. The rugged turning drive has been designed for 100,000 hours working life without any replacement of major elements. The shelter provides all-weather accessibility for routine inspection by maintenance personnel. The turning drive is capable of rotating the extra load of a standard secondary radar hog trough, or that of the new 28-foot Marconi messenger antenna just shown. This is one of two transmitters which are used either in main and standby or diversity configuration to give the system high operational integrity. The choice of output device was made on the basis of cost per operating hour against mean time between failure. The improved 14-port magnetron, linked with a fail-safe solid-state modulator, provides a simple high-stability combination. As no extremely high voltage supply is used, the system is both safe and reliable. Accessibility for maintenance is very good. And of course, the performance easily meets all recognized standards for a radar in this category. Use of advanced technology made practicable the design of the signal processor. It is a unique self-adaptive 3-parallel channel design with exceptional capability to reject clutter. The Marconi processor sets new standards for target visibility, both in severe ground clutter and in heavy precipitation. A comprehensive byte system allows rapid fault finding to line replaceable unit level. Overall, the S511 system mean time between failure for a dual-channel installation is an impressive 6,000 hours. The Marconi Astra display system seen here is an optional package for the S511. It provides good picture quality, performance, and system flexibility at a competitive price. This Astra display is showing the radar picture at Southend Airport, which is 38 miles east of London. The range scale selected is 64 nautical miles, and the range rings are at 10-mile intervals. The digital map shows the coastline of southeast England and the Thames River estuary. The airways and the London TMA are here and here. These are the London airports at Heathrow, Gatwick, and Stansted with their control zones. And this circle is the Southend local control area. This is a view of the air traffic around London on a typical winter afternoon. The single-channel S511 radar installation at Southend provides good coverage for both approach control and general surveillance. The display is selected to 32 miles range. The almost complete absence of clutter and false alarms make it particularly easy to interpret. The new signal processing technique used on the S511 always provides the controller with the best possible picture, a picture assembled continuously from the outputs of 3 parallel processing channels. In practice, the controller has the facility to superimpose a map of fixed and weather clutter onto the processed radar picture. This ghost clutter will be at a lower brightness level than the radar traffic picture, which is therefore easy to distinguish. A shorter range scale is used for surveillance radar approaches. A single-engined Cessna aircraft can be seen turning onto final approach to Southend. Tangential fading, which is a classic radar problem, particularly on this final turn, has been virtually eliminated. S511 has a minimum range of less than 1/4 mile from the radar. With suitable antenna sighting, this excellent short-range performance enables aircraft to be seen to touchdown point on each runway. The ICAO specification permits surveillance radar approaches to terminate 2 miles from touchdown. However, the UK Civil Aviation Authority has certified the S511 down to 1 mile. And this limit is not imposed by radar performance, which is quite satisfactory to below 1/2 mile. The S511 is the first approach radar to have achieved SRA certification in the UK against current aircraft operating criteria. In the past, weather clutter has been a major problem with 10-centimeter radars. Circular polarization on the antenna helps, but processing systems often remove weather and aircraft together. The new S511 processing subordinates weather clutter. It removes residual weather effects after circular polarization, so that aircraft are clearly revealed. As an option, a separate weather channel may be incorporated to allow the controller to superimpose a complete weather pattern for any selected operating level on the radar display. Secondary radar plots from either a co-mounted or remoted beacon system are displayed synthetically as labeled markers. This is an expanded view of plot-extracted radar beacon data. Track labels show identity and flight level. The ID code can be replaced by call sign, and as an option, ground speed data may be added. Combined primary-secondary radar extraction is available as an option. This enables economic narrowband transmission of display data to a remote control center and/or maintenance base. The monopulse beacon techniques employed in Marconi Messenger provide a very accurate, technically advanced, and cost-effective sensor system for current and future ATC applications, with full Mode S potential. Newcastle in northeastern England is typical of the busy, profitable regional airports the S511 was designed for. It handles well over 1 million passengers a year and about 33,000 aircraft movements. But its S511 radar handles a large number of overflying aircraft as well. We are about to watch a surveillance radar approach on Newcastle radar. A British Aerospace Type 146 feeder liner is approaching the final turn. The radar picked it up more than 60 miles out and will now provide the dependable accuracy the controller needs for a surveillance radar approach.
Speedbird 146, 8 miles from touchdown. Turn right, heading 07, final approach. Your descent will begin at 5 miles. Check wheels.
Speedbird heading 07.
While he sets up for the talkdown, let's consider the S511's leading features and benefits. Detection range, 55 miles on 1 square meter target. Instrumented range, 64 miles. Peak power of 650 kilowatts. PRF, 1,000 pulses per second, giving high resolution. Pulse width, 0.85 microseconds for short-range detection. Horizontal beam width, 1.5 degrees, a sharp picture. Data rate, 4 seconds, control task orientated. Status reporting and control can be remote for staffing economy.
Speedbird 146, approaching 5 miles from touchdown. Commence descent now to maintain a 3-degree glide path.
Bravo Alpha leaving 1700 feet.
4.5 miles from touchdown. Height should be 1400 feet. Slightly right of track, turn left 3 degrees, heading 067.
Heading 067, Bravo Alpha 1467.
4 miles from touchdown, height should be 1250 feet. Turn right, heading 07. You are on the center line. Do not acknowledge further instructions. 3.5 miles from touchdown, height should be 1100 feet. Clear to land, runway 07. Surface wind 060 degrees at 10 knots. 3 miles from touchdown, height should be 950 feet. Heading 070 is good. 2.5 miles from touchdown, height should be 800 feet. Heading 070 is good. On track, 1 mile from touchdown, approach completed, out.
We at Cincinnati Electronics believe that the S511 is a radar admirably suited to the user priorities of the USA non-federal airport market, and we're backing its introduction with our full resources. Not only by solid domestic logistical support, but with commitments to the full range of marketing and sales activities through equipment production, system integration, and turnkey project management. We plan to make it an outstanding radar value in the USA.